series. Okay, so here quickly we will go about all the concepts and formulas. So let's start. This concept is from geotechnical engineering. It is regarding seepage velocity. Seepage velocity, it is denoted by Vs, and the formula is Vs is equal to V upon N. Now what is V? V is your theoretical velocity. Okay, this chapter is related to permeability, and N is your porosity. Okay, so seepage velocity, basically that is your actual velocity. Now what is the concept behind it? Whenever some water is to be passed through some soil sample, this is your soil sample. Okay, so we will be considering the cross section area. Suppose this is your let me write it B. So this is the base. Okay, so whatever cross section area of this soil, okay, so water will pass through it. So we are considering the whole cross section area, but actually the cross section area is not to be considered totally. Okay, because see, these are the soil particles and the water cannot percolate through the solid particles. The water has to pass through the voids. Okay, so the ultimate cross section area is less. Okay, because the water will be passing through the voids only, so area will be less. So what will happen? We know that what is discharge? Discharge is Q is equal to area into velocity. Okay, so suppose area is less, then velocity will be more. Okay, so actual velocity is more. So seepage velocity, that which is actual velocity, that is Vs is equal to V by N. N is your porosity. Okay, same way, if we are talking about Kp, Kp is coefficient of percolation. So Kp is equal to K by N. Okay, so remember this thing. Remember another thing. Let me change the page. Darcy's law, it is also, you can study in permeability chapter, Darcy's law. So it is specifically for laminar flow. Remember this thing, it is for laminar flow conditions. And that too in a, so this is first condition, and second condition is in a saturated soil. If these two things are satisfied, then the rate of flow or discharge per unit time is proportional to the hydraulic gradient. Okay, so basically the rate of flow or discharge per unit time. So your discharge per unit time is denoted by small q. So q is equal to KIA. Now this I is your hydraulic gradient. I, and that is H by L. So gradient is with respect to distance. So H is your head loss. So basically what is hydraulic gradient? Head loss with respect to the distance. or gradient. So can I write Q is equal to K? Head loss will be from H1 to H2, so H1 minus H2 divided by L into cross section area. So here K is your permeability. So what is K? K is your permeability. Permeability, the unit is centimeter per second or meter per second. So basically it is the ability to pass the water. So it is having the unit of velocity. So V is equal to Ki. Okay, so whenever hydraulic gradient is 1, suppose I becomes 1, then V is, velocity will be equal to permeability. So we can say that permeability is having the unit of velocity, that is centimeter per second or meter per second, anything. Okay, so another thing you may remember, Darcy's law represents the statistical macroscopic equivalent of the Navier-Stokes equation of motion. Many times this type of questions they are asking in MCQs in engineering service exam also. So remember this, that Darcy's law represents the statistical macroscopic equivalent of the Navier-Stokes equation of motion for the viscous flow. Viscous flow. Now I am underlining this viscous flow because this is also important condition, viscous flow of water or groundwater. Okay. Now another main point which you have to remember is Darcy's law is valid for sands, silts and clay. Okay, so basically it is valid for all type of soil, either it may be sand, either it may be silt or clay, but the thing is you have to see all these conditions, that it should be saturated, okay, the water flow should be viscous, okay, viscous flow or laminar flow, and saturated condition should be there. So these conditions are the main prerequisite conditions, we can say. Okay, and you can remember this equation also, K is equal to A gamma W upon eta. So here you can see that permeability is directly proportional to the area, cross section area. If cross section area is increasing, your permeability will increase. Gamma W is your unit weight of water. Unit weight of water, we all know unit weight of water is how much? 9.81 kilonewton per meter cube, and eta is your viscosity. Okay, so mostly viscosity, that is dynamic viscosity only, Newton second per meter square, we know the unit also. Okay, so now there are two tests. One is constant head permeability test, and another is falling head permeability test. The formulas are also different, but remember constant head from C, you can remember it is for coarse sand. Okay, and this is for fine. Okay, So fine means anything, clay. Okay, so fine, and so falling head is applicable for clay, and for sand it is applicable, constant head permeability test is applicable. Okay, so the respective formula of permeability is K is equal to QL upon HAT. Okay, Q is discharge, L is length of the sample, H is the head, A is area, and T is the time. Okay, and same way for falling head permeability, the formula is K is equal to 2.3 AL. Here it is small a, L, divided by capital AT log to the base 10 H1 by H2. So H1 H2 are the fall of water level. Okay, uh, capital A is the cross section of the soil sample, small a is the area of the capillary tube. Okay, so these two formulas, individual formulas, you should know. One is for constant head permeability test, another, this formula is for falling head permeability test. And you should remember, for sand we are applying constant head permeability test, and for clay or fine soil we are applying falling head permeability test. Okay, thank you very much.